Welcome to Isha Training Solutions, guys. This is Kumar Gupta. Well, there was a lady called Priya who has called me and asked me one simple question as to, she's been attending interviews and then she asked me a question like, how do we calculate the number of virtual users? How do you calculate the number of load generators that is required for your test? Okay. Or how do you know that a particular LG will support these many number of virtual users? Okay. Or in other words, how do you know the memory footprint, or how do you calculate the memory footprint? It's a very simple question. Okay. Generally, people say that for web HTTP, HTML, it's 2 MB per virtual user is what a lot of people say. Okay. So, but how do you actually calculate, or how did you arrive to that number? First of all, I would like to tell you that the memory footprint, okay, changes from protocol to protocol. Okay. And it changes from protocol to protocol. Okay. Now, some of you might be wondering, as I'm explaining, it came to my mind that some of you might be wondering, what is this footprint or memory footprint at all? Okay, I'll come to that a little later, guys. Okay, I was not prepared for that question. As I'm speaking, that question came to my mind that you might have that question. Anyways, so let's try to answer this question. How do you know that how many LGs is required for your test or for your project or something like that? Or simple words, how do you know what is the memory footprint? If you're using the tool load runner, we call that as load generators. If you're using the tools like JMeter or any other, usually people call them as load injectors. Okay, I'm not going to talk about here what is an LG or what is a load injector and all that. Let's concentrate on only this part, like how do you calculate. I was browsing through and I got into this wonderful slide. This is by HP. Okay, so immediately I thought, this is the best way we can explain this one. Okay, I'm going to talk about this a little later. Okay, and as I explain and do the calculations, you will understand what a memory footprint as well. Okay, what exactly that word means. Okay, and don't worry too much about these calculations at this point of time. Okay, so first, let's run a test. Let's run a small test. Okay, I've created a script called booking flight script. Okay, so this is the booking flight script that I've created. Okay, and then I've created a small function as well. I was explaining how to create a custom functions and all that. But anyways, let's not worry about this script at this point of time. Okay, I'm going to execute this script right now from my controller. Okay, I've uploaded already that script, the book flight script, into my controller. Okay, so now let me start the execution with one user. Okay, with only one user. I'm running this for probably 30 minutes or whatever the time, it doesn't matter. Okay, so for this test, and then let me go ahead and run it. So before I run it, let me go to the task manager. Okay, let me go to the task manager. And in the task manager, you look at all the processes. Okay, process is nothing but any program which is under execution is a process. There is a program that you have written and it's not executing, it's a program. Once it is executing, it becomes a process. Okay, so now I have started this test. Then this one virtual user that you have given, who will give that virtual user? The LG will give that virtual user. What is the LG over here? The local host. Local host as in the machine that I'm looking. That particular machine will give you that one user. As soon as I click and start, there is a program in this load generator program which will start executing. Once it starts executing, it will give you that one user, or it will give you that 2 or 3 or whatever you're asked for. So for this load generator to give those users, it has to start executing, or that program, the load generator program, has to start executing to give that one user. And once we know that the program which is running is a process, and that process you can look up over here. Okay, so what is that program which runs to give that one user? That program is nothing but mmdrv.exe. Okay, usually this is nothing but multi-thread driver. Okay, probably that's the reason why they have given the name mmdrv. It's a multi-thread driver. DRV is driver, M is multi, and I don't know the other M what it stands for. So it gives you multiple threads. This driver gives you multiple threads, as in multiple users. Anyways, so this is the program which executes behind the scenes to give this one user. Right now, let me search for that program. Okay, mmdrv. So you see mmdrv is not there. I'm trying to search with M. So nothing is starting with M. I've typed M, but you see nothing is there. Okay, so with starting with the letter M. So obviously this program, which is mmdrv, is not a process yet because we have not started. Any program which is running is a process. Okay, so this program mmdrv, okay, it is not running yet because we haven't started the test. Since it's not running yet, it is a program, it's not a process, and that's why we are not able to see that mmdrv over here. But once I start executing this test, now this program, okay, mmdrv, this program mmdrv is running, which means that it becomes a process, and it became a process. I'll be able to search, as you see, mmdrv. Now it is a process because it is being executed, and as it is executing, it has given that one user. And how much amount of this memory, which is private bytes, is what I say, how much amount of memory that it got allocated? 6504. Wonderful. Okay, what is that? 6504 with how many users? And this is what? It's a kilobytes. It is kilobytes. Okay, it is kilobytes. Okay, and with how many users? It is one user. Wonderful. Now I'm gonna increase it to 2 users. You know, in controller, you can on the go, you can execute, you can increase the number of users. How can you do it? Click on the virtual users, add users, and I wanted to add 1 user. Okay, wonderful. This is down at this point of time, so let me run this program. Okay, sorry, let me run this virtual user. Okay, wonderful. Then now there are 2 users which are running. Okay, which it is quite evident from here as well. Now this program called localhost LG has given 2 users. This localhost is running which program? mmdrv program, and this mmdrv program is giving how many users now? 2 users. And let's see the memory consumption at this point of time, which is 7400. Wonderful. Now with 2 users, it is 74. How much is it? Sorry, 7400. 7400. And how much? This is the private bytes, guys, which is the memory kilobytes. With how many? 2 users. Probably you might have thought that with 1 user it's 6504. With 2 users, this should be double of this. Okay, it should be double of this. Should be around 1300 kilobytes, but that's not the case, guys. It is not 1300. It is 7400 kilobytes. Similarly, let's increase it to 3 users and see how much it is. We are doing these experiments, guys. So in this experiment, I want you to you are participating in this experiment to understand how to calculate this memory footprints. Let me add 1 more user to it. Okay, and let me bring it to running state, and this 3rd user is also running the same script, which is the booking flight script. Now all the 3 users are running the same script, which is the booking flight script. And then let's look at the memory consumption at this point of time. It is supposed to increase, which is 8064. Okay, 3 users, 8064 kilobytes. Is this bytes, kilobytes, megabytes? It's kilobytes. Okay, so let's calculate, let's delete this one from this one, okay, minus this one, which is 896 kilobytes. Just out of curiosity, I'm deleting the memory of the 2 users with 1 user. This is 86. And similarly, I'm deleting this one with this one. Let's see how much it will be. The memory taken by 3 users minus the memory taken by 2 users, around 600. Usually this number will be same, more or less same, with little variance, but here the variance is little more. Okay, but that is fine. Now let's look at the four users, how much it is. Okay, one more user. Let's bring it to running state, and the 4th user is also running the booking flight script. Wonderful. Okay, and this is also in the running state. Close and come to memory footprint. It is 8852. Okay, with 4 users, it's 8852. Not memory footprint, the memory taken by the users, the private bytes. Okay, and let's look at the difference. again 790. So if you look at the average of it, it is close to around 800. Okay, so this number, whatever you're looking at, it is close to 800. So if you're going with 5 users, okay, can anybody guess how much memory it will be taken? 8854, okay, 8854 plus somewhere around 790, 700 or 750. So let's look at as 790 or 800. Okay, probably it will be around 9600. Okay, 9600 or anywhere around that. Okay, so I'm not saying exactly this number, but anywhere closer to that. Okay, let's add that one user. How do I do it? Go to users and then add one user, click on OK and make sure it is in the running state. This is down at this point of time. Run it and make sure this is in the running state. Now go back to the private memory 9460. Okay, somewhere close to it, 9460, 9460. Okay, so this is in the kilobytes. How much is the difference again with 5 to 4 users? This one minus this one. Okay, around 600. You see, somewhere around 700. If you take an average of this, okay, so if you take an average of this, okay, sum of, okay, is equal to this divided by 4. Okay, around 730. Average is 730. So every time you add a user, approximately around 700 bytes to 730 bytes will be added. Anywhere from 700 to 800 bytes will be added. This seems to be an exception, you can ignore it, but anywhere from 700 to 800. Okay, okay, and on average anywhere from 600 to 800 or 900 will be added. On an average 700 will be added every time you add a user. So 700 kilobytes on an average, 700 kilobytes will be added to the existing memory. Okay, so you see, initially for the first user, it's not 700, but a huge chunk of memory is added. But after that, close to 700 kilobytes is added every time you add one single user. Why the first user, not 700, or yeah, on an average, if you consider this as 700, why not the 700 KB? Why the 6500 KB? And after that, why every time a user is added, around 700 KB of memory is added? Why is it? I'll answer that right now. Let's go to the PPT. The very first user, what happens is, okay, for that mmdrv, the process to run that, there is this common memory that is added. Initially, that common memory is added, and for that one user, there is this private memory or the private part is added. That's why for the first user, this memory plus this memory. For the process, the mmdrv process to run itself, there is this common memory. By default, it will be added as soon as the first user is added. So this is common to all the users, and this is that single part which is coming to our 700 kilobytes is there, right? That is this part. And when these two users are added, obviously this common part will be there, and this is for the first user, for this second user. In our case, this is what? 700 kilobytes. This is for almost approximately, it will not be accurate 700, but approximately 700 KB. Sometimes it could be 600, sometimes it could be 800, but approximately 800 kilobytes, okay? And this common part will be there. If there are 3 users, so the common part will be there, 700 kilobytes, 700 kilobytes, 700 kilobytes. Now you wanted to understand how much this one is. Simple, guys. In our case, okay, so this one, okay, this memory plus this memory is what? 6504, okay, this one plus this one. And then in 2 users, this one plus this one plus this one is what? 7400. You have deleted this one minus this one, so you have deleted this minus this, so you got the memory for this one. Okay, now what I want, what I want is this memory. Simple, you already have this memory. How much is this? 700 kilobytes. And you already have this memory, overall memory, which is 6540. You want this memory. How much? What you will do? 6504 minus 700, okay, because this memory is what? 700. Overall this memory is what? Okay, let me write it down here. Okay, let me see if I can write it. Okay, so overall this much, how much it is? 6504. Okay, so if you look at that Excel sheet, okay, keep, okay, So if you look at that Excel sheet, it is 6504, which belongs both this one and this one, which is with the first user. And only this part, how much it is? Approximately 700. Okay, so let me do a shift F5. Okay, only this part, how much you got it? How much it is? This is 700, approximately 700. It is changing, but on average it is 700 KB. So you want this memory, how much it is? 6504 minus 700. So that's what I'm gonna do. Okay, so is equal to 6504 minus 700. Okay, 5804. So now you got this memory, which is 5804, or let me round it off to 5800, 5800 MB, and you got this one, which is rounded off to 700. So you got both these now. Okay, so shift F5. Okay, so this is what? 5800. Okay, and this is 700 approximately. Okay, now in load runner, one mmdrv process, one process will support, there is a limit to which it can support the number of users. It is 50 virtual users. One process will support up to how many virtual users? 50 virtual users, which means that it has the enough memory for 50 virtual users. After, if you are executing with 51 virtual user, one more mmdrv process will start, and then it will start adding the virtual users to it. Okay, so whatever the allocation that you're seeing, this common part that you're seeing, it can support 50 users. So now you wanted the memory footprint. Memory footprint means for one user, okay, for one user, how much memory you need. Okay, what is this memory footprint? Now I'll come to the definition of memory footprint. Okay, as I've told you, as I've discussed, I'll tell you what is a memory footprint. Okay, so memory footprint means for one user, how much private bytes or memory is required. Okay, blindly some people will say that, oh, for one user I'm subtracting two users with this one, and then it is 896. I've took the average of it, it is 700. So one user, okay, one user will take 700 MB, sorry, 700 KB. That's incorrect, because this 700 KB only, okay, where is the PPT? Is the PPT over here? Only talks about this one, but there is a common part as well, which is shared by all the 50 users. So this common part will be shared by how many users? 50 users, because this supports maximum, this process supports how many? 50 users. So this common part also is there, which needs to be distributed. So you have to divide, this common part will be shared across all the 50 users. So you have to divide this by 50 users. So I'm going to divide that with 50 users. The common part is how much? 5800. So 5800 divided by 50. So the common part is how much? 1116. Okay. So now the memory footprint is for one user 700 KB plus this common part, which is distributed across all of them, which is 116. Okay, I would say the memory footprint for this particular script for HTTP protocol is how much KB? Close to 1 MB is what I can say. Okay, 1 MB, or you say 816 KB. It can never be accurate. You can round it off to 1 MB. Okay, 1 MB is 1026 KB. Okay, so usually people say with all the script complexities, my script here, booking script, is little simple, straightforward. That is the reason why the memory footprint is 1 MB. But if you have some complex scripts, what I have seen is it is close to 2 MB. Okay, so 2 MB, lot of people say 2 MB. Is that incorrect? No, but you have to, in the interview, they are talking about this. Okay, if you explain all this, I'm telling you, the interviewer is gonna go flat. Okay, because he wouldn't have explored all this. Okay, so now, and you see everything that whatever I've done, you know, it's true. You can clearly see that. And this is from HP. I'm not cooked it up. Okay, as you can see this HP logo. So, and we have done this little experiment with one user, with one script and all that. You could see this. Okay, so the memory footprint is 1 MB. Okay, for my script now. I hope you got that idea as to how to calculate the memory footprint, guys. Okay, I hope this video is useful to you and help you to crack the interviews. And also if your manager is asking, or before the project you need to know how many LGs is required, then this is the way you can look at it, the memory footprint, and you can see if your LG is, let's say, if your LG machine is, let's say, 16 GB. Okay, so based on this you can tell that, you know, one user is taking 1 MB, so 16 GB means how many users that particular LG can support. Based on that you can do your math. But this is only the memory. Okay, but this is only the memory. Okay, but there is CPU as well, there is disk as well, and you know, for whatever the number of users that you are looking at, you know, it should support the CPU and disk as well. Okay, so what are the factors which influence that CPU, disk and memory? We will dig more deep into it in the next slides. Okay, so I hope it is very clear now how to calculate the memory footprint. Memory footprint is nothing but for one user how much memory is taken, and then there is a private part and there is a shared part as well. And the private part, 2 users minus 1 user, you calculate the memory for 2 users, and then you 2 users and you subtract with 1 user, then you get the memory for the private part, and then the overall for 1 user minus the private part. Okay, so we'll get you the memory for this one. The same calculations are given here, guys. Okay, and then the overall footprint is that X divided by 50 plus this one will give you the memory footprint. Okay, as you can see, this is the common part and this is the private part. So this is how you calculate the memory footprint for your scripts and all that. So Kumar sir, is this the same 1 MB for my script as well in my project? Okay, hold on. Okay, this memory footprint of 1 MB that I have calculated is for my project, for my script, which is booking flights. Okay, for your project and for your script, it could be same, it could not be same. You have to do the same experiment. But why it changes? Why it changes? Okay, so you see, every user's memory footprint is greatly impacted by the following factors. One is the number and size of the parameters. Parameters means LR parameters. You declare that LR parameters, right? Okay, over here. So how many parameters you have declared? Okay, and also you can declare the parameters over here as well, right? On the go you can create LR save parameters, you can do, right? So this is also LR save string or LR save int. What you're doing, you're creating the parameters on the go. Okay, so those parameters, it depends on the number of parameters. Okay, so how many parameters are there? More number of parameters are there, more will the memory footprint. Okay, that is the reason why I'm saying it. The memory footprints will change from script to script. Okay, it changes from project to project, but more or less it will not be like it doesn't jump from 1 MB to 10 MB. It might jump from 1 MB. The memory footprint for the script 1 could be 1 MB. The memory footprint for script 2 could be 1.2 or 1.3 MB or 0.8 MB. There will be the 20 to 30% variation depending on the number of parameters. Okay, and the size of the parameter as well. Okay, and then size means you see that web set max HTML param length is what you declare, right? By standard it is 1024. That's what we are talking about, the size here. Okay, and the number of lines code included in the recording. Okay, so here if you see my script has how much, close to 300 lines of code. Okay, but if you go to the scripts like Salesforce or SAP Web, you have 3000, 4000, 10,000 lines of script. So that lines of the code also greatly impacts the memory footprint. And then the size of the driver library. This is fairly static. It doesn't change from script to script. This is created by the HP itself, or right now it's Micro Focus itself. So you need not have to worry about that. Okay, but these factors define the memory footprint. Okay, that's why project to project, script to script, there will be a variation. It cannot be one standard number. But earlier I've shown you how to calculate the memory footprint. Okay, the 1 MB that you have looked at, it is for my project, for my script. Okay, now only memory footprint? No, CPU is also there. You know, you want to run the program. That program which was static, now it became into running state and you start calling it as a process. How come it became a process? Because of the processing unit. Okay, that processing unit, the central processing unit, has provided little bit of its time to it, so that, you know, that program became a process. Okay, so obviously that mmdrv process is running, it is running because of the CPU, and obviously it will utilize the CPU percentage. Okay, so the amount of CPU used by load runner generator will vary by following factors. Okay, so number of iterations you are running, how much is the pacing, okay, that defines. And if you're running a stress test, obviously you will decrease the pacing and everything and increase the number of users, so that will also impact the CPU utilization. And you have some customization code, or something, string manipulations, you have added a lot of string manipulations and all that in your script, which takes certain CPU, so that also matters. So CPU more or less doesn't matter, but it is greatly affected by these things. But whenever you purchase a machine, right, you go to any store, okay, who is customizing your desktop, okay, then let's say I go to my CTC here in Secunderabad, the Isha Training Center. I went there and I said, okay, I want 4 core, okay, but I want 64 GB RAM. Immediately he said, Anna, why for 4 core you want 64 GB RAM? You will be wasting all the RAM. 4 core maximum you can go is 16 GB or 32 GB. After that, even though you are adding the RAM, it's useless because it's not going to use it. So generally, if there is a machine that is designed for that particular memory, the same amount of CPU or the processing unit will usually be assigned. You need not have to worry too much about it. But these are the things which are factored in. Okay. Now the disk part. Okay, disk, how does the disk, how much disk will be utilized by this and all that? It depends upon the logging. How much of logging you are doing. Okay, so if you're trying to log everything, here I did a standard log. Okay, which means that little thing will be written into the disk. Okay, but if you want to go with an extended log and you're including all this, lot of stuff will be logged in by the load generators. Okay, which means that it has to write everything into the external drives. Okay, all that log, so it's gonna consume lot of disk. Then you have to consider, your LGs might become slow and all that. So the disk utilization also, it depends on the logging. And sometimes what happens is, you use the file operations in your script. Okay, fopen, I don't know if you have used this fopen, fwrite. Okay, something, you got a transaction number, you wanted to write that to external file, then you use this function called fopen, okay, and fwrite, okay, and then fclose. Okay, I don't know if you have used it, because this is frequently used if you wanted to write something from the script to external file. So if you're using something like this, then there will be a lot of disk utilization, and you will have to consider that as well, not just memory CPU but also disk. Okay, so and then you have to be careful about it. You have to run it, see what is the disk utilization, and based on that you have to see if you have to how your LG should be, how much disk should be, and how much processing should be, and all that. Okay, and external drivers, if you are adding any external drivers, which I haven't done all my life, but some very smart people might be adding some external libraries. If that is so, you have to consider all that. But typically in the interviews, as long as you are talking about the memory, the way you have done the calculations, you are explaining about it, and you are talking about this memory, saying that okay, it changes from script to script and you have to calculate, and project to project, and these are the things which are important to be considered, I think you are good to go. Okay, but in the real-time projects, I don't think, because for the LG, they're spending millions, if not millions, $100,000, $200,000, even $300,000 for the projects. Okay, usually I give a lot of proposals. Any simple project will be $5,000 to $10,000 in terms of we doing the project. Okay, so $5,000, $3,000. I mean, I do for even $1,000, $2,000, because however I'm working, so I make sure that there is enough work for me. So, but if you go to TCS or something like that, they give any simple project $25,000, $15,000, or $30,000 per project for the execution and for the tool licensing. So all that will be $60,000, $70,000, $80,000. And for that, if they have to buy one LG, how much it will be? $500, $600, or maybe $1,000 max. Okay, they can just buy the LGs like that with a 64 GB or 32 GB. So you don't really get into all these calculations, to be honest. Approximately a ballpark number you can tell. Recently, I've done a project for my bank, for one of the banks in Saudi Arabia. And they asked me, like, we are running the test with 1,000 users, and we had to run the test with 1,000 users, and they asked me how many LGs or load injectors. We have done it with JMeter, and there you call it as load injectors, here you are calling it as load generators. They asked me how many load injectors you need. 1,000 users, I did some blind calculations and said 3 should be good and 4 should be enough. In on the go, with my experience, I didn't do all this memory footprint and then LGs and all that. I make sure that they give me more, so that we are on the safer side. In the worst case, if you are underutilized also, I'm fine, but at the later point of time, I'm saying that this is not enough, I need more machines. They might get pissed off. So I'm all not only me, everybody thinks in that way. And allocating a machine is not a big deal. I mean, they need not even have to purchase, all the people, all the companies have a lot of machines with them. They just have to allocate. So they have allocated those 4 machines, and I end up using only 2, to be honest. But I kept saying to them that I've used all of them. Anyways, that's the story, guys. So now you understood this, how this LGs work, what is this memory footprint and all that. Okay, one prerequisite to watching this video, guys, I should have said this, is you need to know what is a load generator, load injector before watching this video. Otherwise, you would not understand a single word I've said. Okay, take care, guys. Bye bye. And next time I come with more videos. Anybody has any questions, post it to me. Thank you. Take care. Bye bye.